We present a robotized installation for the automatic assembly of cylinder heads for a family of motors. It occupies an area of about 70 by 30 meters and consists of 44 assembly stations plus 4 control stations. It assembles 154 pieces an hour, corresponding to a time cycle of 30 seconds, and is equipped to produce 35 types of cylinder heads where the number of combinations of elements mounted exceeds 150. The installation has as its objective an elevated level of productivity, high flexibility, and easy operation. It consists of 3 parts: assembly of cylinder head components, assembly of overhead components, and assembly of miscellaneous components. The key element in the operation of the installation is the StaTech electronic codifier, coupled with each pallet. With its 512-byte memory capacity, it accompanies the successive phases of assembly, memorizes and transmits information which is utilized to diversify operations, and commands the rerouting of the pallet to repairs in case defective operation has been signaled to the control station. Data relative to the type of head being assembled and its production period are fed into the codifier memory. The wash and blow-off tunnel guarantee a perfect cleaning of the head and the pallet. After lubrification of the valve guides, the first operative station is the assembly of the intake and exhaust valves, affected by 2 robots. Valves are fed in packs, which are transferred on different lines according to the type required. The cylinder head is then turned over and located on its pallet, which then transfers it to the other operations and finally to the unloading station. A pair of robots inserts the oil seals. This operation is carried out individually for every valve stem. The formation of the spring package, that is the washer, lower retainer, spring, keepers, and upper retainer, is an auxiliary circuit equipped with its own pallet. The function of this circuit is completion of a series of closely related operations without hampering the principal line of assembly. Its operation is distributed among 4 robots. In a first operation, 2 carry out the formation of the spring package. In a second, the other 2 after the connection of the keepers, effect the assembly of these in the retainer and their transfer to the spring package. The pallet with 4 lines of spring packs is now presented to the principal line of assembly, where an automatic unit picks up 8 at a time and, utilizing the pushers with which it is adapted, slips them around each valve stem. A checking station verifies that every valve stem is completely and accurately assembled. If it is not, this station provides for its transfer to repairs. We have simulated a reject situation by badly placing 2 of the valves in the group. The STATEC of the pallet shown recognizes the irregularity and commands its transfer to a repair line. Here, a display panel visualizes the rejected valves. On the principal line of assembly, meanwhile, a manipulator and a separator pick up the tappets from a moving supply belt and loads them. The following station is intelligent and decision-making. In fact, the reader of the STATEC recognizes the cylinder head in transit and transmits data from it relative to the positioning and loading of the proper overhead in order to guarantee correct pairing. We transfer ourselves now to the beginning of the overhead line. A unit verifies that overhead and camshaft correspond to the data memorized on the STATEC of the pallet. Following this, a first station carries out the placement of the camshaft in the overhead. A second station controls the free rotation of the camshaft and the insertion of a ring. A gasket is then placed on the overhead, and this assembly is then moved toward the central line of assembly for union with the cylinder head. The transverse line of the installation is dedicated to precision measuring of the cylinder head and overhead in order to determine the play between the tappets and the cams. The 2 measuring stations are furnished by Marpos. For the cylinder head, the distance between the gasket surface and place where the shim will be mounted is measured. For the overhead, the distance between the gasket under pressure and the camshaft collet is measured. The measurements relative to overhead and cylinder head for each of the 4 cylinders are memorized in a station equipped with a storage for 59 shims that vary only in their thickness. The selection of the shim is a function of the difference between the measurements of the overhead and cylinder head. The 8 selected shims are picked up from storage and mounted on their corresponding tappets. A setup and check station completes these operations. The two heads are transferred onto parallel conveyors. In this station, two robots transfer with precision the tappets from the cylinder head to the overhead. A rollover system couples the overhead to the cylinder head. The overhead pallets are now empty and returned to their starting position. The assembly of washers and bolts is carried out by two robots in combined operation. An eventual operational error is signaled on the StatTech. In a following station, a wrenching unit completes the tightening. The following section is dedicated to the verification of tappet play. The test is made by an automatic unit with rotation of the camshaft. This station also signals rejected parts to the manual repair area. Repaired parts are sent back to the unit for retesting. The preparation, the bolt start, and the tightening of the camshaft cover bolts are carried out by two robots. The first prepares the cover, gasket, washers, and bolts subassembly. The second transfers the subassembly to the head, starts the bolts, and then using a single spindle wrencher, torques the three bolts individually. The studs are placed and tightened on two parallel lines for production requirements. A distributor feeds the two lines. Here we demonstrate the high degree of flexibility achieved. Every robot mounted vertically holds a gripper and wrenching group and picks up individually the studs from the feeder, places them, and torques them on the head. The operation continues with the automatic insertion of two gaskets for the manifolds and the selection of the intake and exhaust manifolds. The tightening of the manifolds is carried out in the following station. A final repair area is provided for eventual correction of the studs and manifolds. The installation, one of the first examples of intelligent integration of robots in a high production assembly line, responds to the proposed objectives in that high productivity is guaranteed by extensive use of automation, flexibility is assured with the use of the 22 robots employed, and ease of operation is achieved through inspection stations and repair areas for rejected parts. This installation permits the realization of a new production management rate in which manpower is mainly utilized to control the flow of incoming materials and for maintenance.